We have another example on the board. This problem is a little bit different. Please notice that we have given R1 and we have given R2 and R3 is missing. R3 is in parallel with R2, okay, and we have just given current I3. So let me redraw the circuit first, okay. I'm going to have voltage source and I have resistor R1 and I'm going to have resistor okay, this is resistor R2, 3. This is the combination of these two resistors together, okay? So I'm going to look at this circuit like the series circuit, okay? So what I mean by that? Please notice that R total is given. Okay, so I can write that R total is equal R1 plus R2, 3, right? But I have R total, I have R1, I do not have R2, 3. So I'm supposed to solve this formula for resistor 2, 3. If you are going to solve this formula for R2, 3, you are going to have R total minus R1, where R total is equal 25 kiloohms minus R1, which is equal 15 kiloohms. Everything is equal 10 kiloohms, okay? So I found that R2, 3, the combination of these two resistors, okay? These two resistors are in parallel, give me the value of 10 kiloohms. Now, so I have the total resistance of resistor R2 and R3, and I have R2, so now I can use the formula called product over the sum. R2, 3 is equal R2 times R3 over R2 plus R3. This one is given, R2 is given, I can find R3. So in order to solve this formula for R3, I have to multiply both sides of this formula by the denominator. So I'm going to have R2, 3 times R2 plus R3 is equal R2 times R3. Distribute R2, 3 into the parentheses, so you're going to have R2, 3, R2 plus R2, 3, R3 is equal R2, R3. I'm looking for R3, that's why I'm going to bring all terms which contain R3 to one side. So I'm going to bring this to the right side, okay? So I'm going to have R2, 3, R2 is equal R2, R3 minus R2, 3, R3. Next, I'm going to factorize R3 because I'm looking for R3. R2, 3, R2 is equal R3, and I have R2 minus R2, 3. If you are going to divide both sides equation by whatever is multiplied to R3, in this case I have to divide by the parentheses, R2 minus R2, 3, and I have R2 minus R2, 3. This one and this one will cancel out. And I have formula for R3. R3 is equal R2, 3 times R2 over R2 minus R2, 3. Okay? So now I can plug in the values and find value of R3. R2, 3 we found is equal 10 kiloohms. So I have 10 kiloohms times R2, and R2 is given 15 kiloohms over R2 15 kiloohms minus R23, which is equal 10 kiloohms. Everything is equal 30 kiloohms, okay? So R3 is equal 30 kiloohms. Okay, so I can cross this out because I found it. So now I have resistance R3 and I have current I3. That's why I can find very easy the voltage across resistor R3. So V3 is equal I3 times R3. I3 is equal 8 milliamps times R3, which is equal 30 kiloohms. Everything is equal 240 volts. Okay, so this is my voltage across resistor 3. Okay, I found this because I have current which goes through this resistor and I have resistance. I can also find the power. So I have P3 is equal I3 squared times R3, which is equal 8 milliamps raised to the second power times 30 kiloohms is equal 1.92 watts. Okay, so we also find the power 3. Okay, so next, please realize that resistor R3 is in parallel with resistor R2. You're supposed to remember that in parallel circuit the voltages are the same. So I can say that because they are in parallel, V2 is equal to V3. Okay, and this is equal, we found 240 volts. Okay, so I have voltage across resistor R2. If I have voltage across resistor R2, I can find the current which goes through the resistor R2. I2 is equal V2 over R2, where V2 is equal 240 volts over R2. This is equal 16 milliamps. So this is the current which goes through resistor R2. Because I have current and resistance, I can also find the power. So if P2 is equal I2 raised to the second power times resistor 2, this is going to be equal 16 milliamps raised to the second power times R2, which is equal 15 kilos. So P2 is equal 3.84 watts. Okay, so this is the power at this resistor. Next, because I know already the current which goes through this resistor, and I know the current which goes through resistor R3, I can use the KCL, which says that the sum of these two currents is going to give me I total, okay? So this is going to be my I total and also I1. So I can say that I total is equal I1, and this is equal I2 plus I3, where I2 we found is equal 16 milliamps plus I3 we found I3 is given, so I have 8 milliamps. So I total is equal 24 milliamps. Okay, this is my I total, and this is also equal to I1. Please notice that total current will go through the resistor R1. That's why I total is equal I1. So we found I1, we found I2, we found I total. Okay, we found also P2. So we found also V2. Now we can find V1. V1 is equal I1 times R1, where I1 is equal 24 milliamps times R1 15 kiloohms. This is equal 360 volts. Okay, so let me just draw the border, just make sure that we're not going to be confused. So we have voltage across resistor R1 and we have voltage across the combination of these two resistors. So in order to find voltage source, you're supposed to simply add the voltage drop across resistor R1 plus voltage drop across resistor R2, 3. Okay, so V2, 3. So we found that V1 is equal 360 volts plus V2, 3 is equal 240 volts. Okay, don't forget, if you have voltage across resistor R3, okay, the same voltage is going to appear across resistor R2 because they're in parallel. Okay, so V2 is equal to V3. We can also call this V2, 3. So everything is equal 600 volts. Okay, so this is my voltage source. Okay, we found also V1, and now we can find P1. P1 is equal I1 raised to the second power times R1, where I1 is equal 24 milliamps raised to the second power times R1, which is equal 15 kilo. Everything is equal 8.64 watts. Okay. Next we can find P total. P total is equal I total square times R total. So this is again 24 milliamps raised to the second power times R total, which is equal 25 kiloohms. This is equal 14.4 watts. It's always good to check if the answers are okay. So if you want to verify your answer, okay, if it comes to the power, you're supposed to simply add all powers together. I mean P1, P2, and P3. If you are going to add them up, you're supposed to end up with the value of 14.4 watts. I add them up and I end up with 14.4 watts. It means that the problem is solved correctly.